Hello and welcome. You are curious about how to design smart home controls for elderly? Then you are at the right place. Let's get directly into it. Currently, there are many efforts to increase the quality of life of elderly by supporting their activities of daily living with digital solutions. Especially elderly which have difficulty moving and are mostly restricted to their homes can profit from smart home technology. Having the opportunity to reduce the distance a user has to walk to achieve a certain goal within their house, like switching on the lights or operating the window blinds, is a huge burden for those that aren't as mobile anymore. Many endeavors exist to improve technology usability and to design it in an inclusive manner. While these efforts can be experienced accessing the web or through user interface adjustments of smartphones for special impairments, there are no direct efforts to adjust smart home controls to the usage of elderly. Our contribution closes this gap. We present a smart home control designed especially with the needs of elderly people in mind. The goal is to enable elderly to profit from the quality of life improvements by easily controlling their smart home. In order to close this gap, the first step is to analyze the current existing solutions and identify the potential of improving these. In a second step, we deduce possible solutions and create mock-ups, which are in the third step evaluated with the target user group. Smart homes are mostly controlled via apps on smartphone, laptop or tablet. In contrast to apps, speech and gesture recognition are alternative input modalities. However, using speech control as single input modality is not really desired due to the possibility to interpret words as commands that are not meant as such. Additionally, misunderstandings and confirmations by the system add a delay. A few smart remotes are available on the market, such as the Nanoleaf remote, the Spin remote, and the Nuimo control. The Nanoleaf remote is 12-sided tangible used to control ambient lighting. Each side can be configured to execute a specific command. It has a drawback that it serves a very narrow purpose. The Spin remote and the Nuimo control are rotation-based and correspondingly touch-based. They are a good example of possible control schemes. However, the Spin remote provides no real indication on which controls are possible, and a Nuimo control uses a touch display, which is not desired in the context of elderly users. 3D printed tangible objects are new approaches for interaction controls. The input is created by placing the objects on the surface of the screen and interacting with them by touching, deforming, and tilting them. While this might be a suitable form of input, adding an additional mean of input that is not immediately recognized by elderly adds another layer of complexity which is not desired. In order to identify which technology for controlling smart home is designed in an inclusive way, we consider existing principles and standards of product design in order to specify the benefits and drawbacks of current solutions. The first set of principles are extracted from Don Norman's book, The Design of Everyday Things. Even though the second set of principles from the Norman Nielsen Group focuses more on the design of digital user interfaces, some of them apply to physical remote. While the two sets of principles are the result of careful consideration of human behavior, wants and needs, we contribute design requirements we find appropriate in the context of designing smart home controls for elderly. We compared and analyzed which design principles have been adhered to or violated in several remote control families. Comparing aesthetic and minimalist design with discoverability, we can see that the ratings are almost inverse since the fluid intelligence of people declines with age. It is important that users are able to recognize and understand the functions provided by the remote while not making it too crowded. Thus, our goal is to create a remote control which satisfies these prioritized principles. Extracted from our design considerations, the cube is the basis of our first concept. Each of the 6 sides represents one device. Each side has a revolving ring as a form of input. Inside the ring, signifiers for possible commands will be shown. A possible implementation would be an e-paper display. This way, the currently selected command can be highlighted while still providing visibility of other sides. The display also functions as a two-part button to allow input by pressing. After choosing a device, for example the heat control, the user can issue a command by either rotating the topmost ring or by pressing down on the middle part. Pressing will produce a change in a binary setting like on-off or start-stop. Rotating will change a value that is part of the scale, like volume brightness or the position of blinds on the windows. A second shape? We consider a cylinder with several rings. Each ring corresponds to a single device. For input, rings can be rotated just like with a cube, as well as pushed down and pulled up a bit to replace the button functionality of the screen. Due to its shape, rotating the rings as a way of generating input should come naturally. Pushing and pulling should be indicated via signifiers and mapped to actions that translate well into up and down movements. The cylinder could be constructed of several stackable modules. Each module would consist of a slice of the cylinder containing one of its rings. This way, rings could be added or removed depending on the user's preferences. To enable widespread use and customizability, both shapes should be able to communicate with the APIs of the most common smart home systems. Feedback is handled via vibration and changes on the display. For power supply, we suggest an internal battery that can be charged via an inductive charging station. The cube mockup was created from foam, which was spray painted to reduce crumbling. The sides consist of revolvable discs of the same material, each fixed with a nail. Graphics of a possible user interface were glued to each side. The cylinder mockup consists of a closed plastic tube with revolvable plastic rings around its body. Both mockups were designed for the same use cases to enable a better comparison. To determine which of the two concepts should be developed further, we conducted a qualitative survey. 10 people participated in the survey aged between 62 and 81 years. Subjects were surveyed in pairs. Each pair was given an introduction about smart home and its possible uses. They were then confronted with an imaginary scenario of them already having a house outfitted with smart home technology and were asked how they think a good controller for it could look like. Participants were encouraged to talk to each other and discuss the topic. Afterwards, they were presented with one of the two mockups. Without further input, they were asked to explore the mockup and guess its functions. Participants were then asked about what they do or don't like about the presented mockup and if it was missing something. After exhausting all opinions and ideas, the process was repeated for the other mockup. To control for sequential effects, 3 of the 5 pairs were given the cube first, while the other 2 pairs got a cylinder first. The initial question about the preferred control scheme resulted in discussions about familiar standard remotes and smartphones. Privacy and security against outside intervention was voiced in 2 of the 5 sessions as a primary concern. 7 of 10 participants preferred the cube model over the cylinder one. 5 of 6 preferred the cube when it was shown first, while 2 of 4 preferred the cylinder model when it was showed second. Subjects began comparing the two models as soon as they were presented the second one. The degree of the preference varied between outright dismissing the cylinder and switching preference towards the cube after learning more about it. They liked the fact that not all information and options are shown at the same time. The possibility to accidentally turn multiple rings on the cylinder was also mentioned as a drawback. Most participants were looking for arrows indicating the intended turn direction of the rings. The provided symbols were not indicative enough. 2 participants also searched for a marked 0 position, however, after additional clarification there was no necessity for these after all. Additionally, a desire for markings was voiced to indicate a scaling of the current position. The amount and type of functions were regarded as sufficient and fitting. The size of the cube was regarded as very fitting. It was mentioned that it should not be smaller under any circumstance due to readability. However, almost all participants were skeptical about actually acquiring smart home technology to use, such as a remote. When posed with the question whether they would use it if they already had access to a house or apartment with smart home technology, all answered with a decisive yes. According to the survey results, we chose the cube, of which we created a minimal working prototype of slightly increased size to fit in the hardware. The casing is made of 2 pieces and the 6 wheels were printed with a 3D printer. The additional indicators that were desired by the participant were added. For simplicity, several intended features were only implemented in a reduced fashion, like a power supply via USB and a small OLED display on only one side. An accelerometer was used to determine the side currently facing up, and direct manipulation is done via 6 rotary encoders, one for each wheel. The goal of the second survey was to see if the participants agreed with the improvements and if they liked the way the prototype can be operated. The participants in the second survey were the same as in the first due to their familiarity with the topic and the 2 mock-ups. After a quick verbal refresher, the prototype was presented to the participants. They got a short briefing on the capabilities of the prototype and were encouraged to pick it up, play around with it, and think aloud. In general, the feedback was positive throughout all groups. All participants liked the increase in size and commented on it being easier to handle. The discrete states, in conjunction with the markings, were received very positively. 3 of 5 groups even desired more resistance when rotating to make the haptic component even more noticeable. In this work, we propose a new smart home control intended for use by older adults. We analyzed design principles which served as a basis in the creation of 2 mock-up concepts, a cube and a cylinder. We then built 2 mock-ups and evaluated them via a qualitative survey with 10 participants. The cube is the more desired model, even though the participants were still unsure whether they would want to actually outfit their own home with smart technology to make use of it. Being presented with a scenario to already own one, the participants were quick to accept the cube as a user-friendlier when compared to smart home controls or touchscreen controls in general.